Alright, so we're Team 2, we're the extrusion screw subsystem. Based off of our, that was spacebar. Arrow?
Space.
Going off of our final design from DR3, we've decided to prove the concept with a prototype. So the prototype is a it's scaled down to half of what the actual dimensions are. We're using a post-hole digger, which is something you put on a bobcat or by hand as an auger in order to reduce cost. The primary validation of this proof of concept is to get an extrusion speed that matches what our numbers say. So that's messing with the RPMs and the horsepower that goes into the auger in order to match an extrusion speed that we have predetermined to make sure that our mathematical models are correct and that will most likely to apply to the full-scale model. As you can see here, we just for economy, we have a wooden stand. In the future, that would most likely be metal, especially when you get up to a larger, or with an actual one, it'd be a larger and more dense and heavy structure, so we'd most likely go with metal. We have bearings on the inside. The backside there, and you can tell it's the backside by the top cut out for a hopper to be put in, which we're thinking could just easily be a 5-gallon bucket that you set in and move the clay through. That backside is completely sealed and secure. That side does not come off. Instead, you bring everything out through the front, so we have to design a point here in order to remove that bearing. The two other validation criteria that we need is the wear and tear on the auger and the wear and tear on the bearings, because those are going to be the primary components that are moving, that are going to need to be replaced, and are going to determine reliability and quality of the brake. Because we were one of the top 3 teams that have to deal with budget, we did include our bill of materials, and I just wanted to let you guys know, as well as the other 2 teams that are in that top area, we're going to have a maximum budget of $480. That's maximum. So with that, we're most likely going to bring it down. The reason is why it's so high is that we put shipping costs in for everything. Most likely you can get a lot of these materials from Poland Building Supply or ACE or Tri-State in Idaho. Additionally, we added $50 for 2 hours of labor in the Coog shop. We'll be doing that ourselves, so you can further reduce that down. So our minimum is $393 for a budget. So going forward from here, as you can see, I mean, we have everything lined up. We're going to be purchasing as soon as possible and building the prototype in order to test. And you guys are more than welcome to bring your systems in, or if you'd like to look at our SolidWorks file in order to adjust your system and your prototype into it so we can get this thing running. That is all for our DR4 presentation. Any questions?